In this video, I will discuss the properties of parallel lines. Let's have a look at the first property. Let me draw two parallel lines. Remember, most of the diagrams that you will get in your examination are not drawn to scale. So there is no point in proving whether these two lines are parallel or not. So we will simply assume that these two lines are parallel. Parallel lines are those lines which are moving in the same direction. They are always the same distance apart, something like a railway track. How can you tell whether two lines are parallel? Usually you will be given an indication, that is an arrow on both the lines representing that these two lines are parallel to each other. If a straight line passes through two parallel lines, it makes angles on both the lines which are equal to each other respectively. For example, A would be equal to P, B would be equal to Q, C would be equal to R, and then D would be equal to S. Now, this property is called corresponding angles. You would simply write A is equals to P, B is equals to Q, C is equals to R, and D is equals to S, and the statement that you will write is corresponding angles. You will have to write which two lines are parallel. So if I name these lines, I can simply say that I am considering AB to be parallel to CD. Moving on to the second property, I can see that A is equal to C because the two angles are vertically opposite, and I explained that property earlier in a previous video. So I will just simply apply that property. A is equal to C. If I look at the first property, I also made a statement that A is equal to P because these two angles are corresponding angles. So P should be equal to A and A is equal to C. I can say, therefore, P is equal to C, and the name of the property is alternate angles, and similarly I will write AB is parallel to CD. It is actually a combination of two properties, or you could write both of those properties, but that would waste your time. So finally we will discuss the last property. The last property relates to the property that we studied earlier, and that was adjacent angles on a line. I can see that angle B and C are angles on a straight line, and they should add up to be 180 degrees. B plus C is equals to 180 degrees, and reason adjacent angles on a line. And I also know that B was equal to Q because these were corresponding angles from our first property. So if I substitute Q in place of B, the equation would be something like Q plus C is equals to 180 degrees. The name for this property is supplementary interior angles. Again, it is a combination of two properties and you have a shortcut. You would be thinking that why should we learn two more properties if we can apply the previous properties? So let me give you an example. If in a question you have two parallel lines and an angle X and Y, instead of applying those properties or extending these diagrams, you could simply say that X plus Y was equal to 180 degrees. And you will have to write that which lines were parallel. Similarly, for alternate angles, if you had two parallel lines, angle X would have been equal to angle Y because they were alternate angles. A new statement for the alternate angles which I hear many of the students saying these days is the Z property. Well, yes, it does look like a Z in this question, but there is no such thing as a Z property, and if you write the Z property in your examination, the examiner would probably write a question mark. There is no such thing as a Z property. It's simply alternate angles. You can have a look at the questions that I have solved using these properties to see how they are used, and that is it. Thank you for watching.